Hey everyone, I wanted to make this video to talk about the linear equation a little bit more, and in particular the constants in the linear equation and how we interpret them. So here's an example of a linear equation: y equals 3 plus 2x. A linear equation always has the form a plus bx, where a and b are two constants, two real numbers. And so here's one example: y equals 3 plus 2x. I can change these a little bit and you can see what happens. I'll do a little bit more of that in a second. Right, so anyway, so these are all linear equations, and take a moment to look at this and think about these two numbers and see if you can think about how they might show up in the graph. So you can pause it, take a moment, think about it. Okay, so one of these numbers might seem a little, well, it's definitely probably more obvious than the other, what it might mean. So this number here, 4, the number that is not multiplied by the x. So this is what we call the initial value. And where you probably saw it show up in the graph is right here. It's the value of the graph when it crosses this thicker line. This is the y-axis, which is exactly when x is equal to 0. So that's where the word initial comes from, in initial value. It's also called the y-intercept. So here I have the definition of it. The initial value is the predicted y value, because remember, we're using these lines to make predictions, when x is equal to 0. So here's x equals 0. I go up, and right where the line hits it is at y equals 4. And it is exactly this constant in our equation. And this makes sense why it's this one, because if you think about the calculation, if x is equal to 0, so if you plug it as 0 here, well, let me actually just go ahead and do it. 4 plus 1.5 times 0, you of course just get 4, because this is 0. Okay, so that's my initial value. And in an equation like this, it is always this constant. That is the one that is not multiplied by x. Okay, so maybe I'll add that here. It is a in the form y equals a plus bx. Okay. So that's the initial value. The other number, the 1.5, that one is maybe harder to see. So for that, I'm going to use the aid of what I have here. So I'm going to unclick this. So here's a generic equation, y equals a plus bx. And here, oh, by the way, I never mentioned, I'm at a website called Desmos.com. It's a wonderful online graphing calculator and grapher and solver. If you've never been here, don't worry about it. Just follow along. If you have, you can try this out if you want. Okay, so here I have these sliders that I can move to change this value. So right now the default is a is 1 and b is 1. So a, remember we just talked about this, is the initial value. So let's look and notice, yeah, the graph goes right through 0, 1. Okay, so that's the 1 point on the graph. It's the initial value. And notice, I can move this. If I move this to the right, my initial value should go bigger. So what's the graph gonna do? Well, it's gonna go up. See? As my initial value gets bigger, the graph goes up because it's intercepting at a higher point. Okay, let's put this at, let's say, 2. Okay. And then here, this number, this is the other constant. Let's see what happens when I change it. When I move it to the right, it becomes, so the number gets bigger and it becomes steeper. And when I move it to the left, the number becomes smaller, becomes less steep, and becomes flatter. Oh, here. Let's move this to 0. It's perfectly fat here at 0. And then once it becomes negative, it's going down. So what do you think? What do you think this is? Okay, so this is called the rate of change. Let's move this to, say, 1.2. This is the rate of change. It's the rate, it's the steepness of the line, right? And it's positive when it's going up, 0 when it's flat, and negative when it's going down. So we need to measure the steepness of something. You need to know basically how much it rises or falls relative to how far it goes this direction. Okay, here, let me use a pen. That is how far from here, let's use a simpler one, 0 to, how far from 0 to here, ooh, and from here to here, right? So this triangle here depicts how far I have to go up relative to how far I have to go to the right. So let's see, let's figure out how far we have to go. So this is 0 to the point, and this is the point 4, 6.8. Okay, so let's do that calculation. Let's do the calculation. Well, what calculation am I talking about, right? Sorry. So it's a rate. Rates are ratios, which means they're division problems, right? So I need to know the change in this direction, which comes from doing a subtraction, right? And then the divided by the change in this direction. So this direction, so this is at, sorry, 4, 6.8. You know what? Let me plot the points for you so you can see them. 0, 2, and 4, 6.8. So you can see those 2 points. Now let's do the calculation. 6.8 minus 2. So this is the difference in the y values divided by the corresponding x values, 4 minus 0. Notice the answer, 1.2, which is exactly this constant that we used here. So this number here, 1.2, sorry, the b constant, the one multiplied by x, is our rate of change. And it tells us exactly this. So the rate of change is the rate of change in the predicted y values relative to the change in the x values. Okay, so let me actually write this in here, right? We found that the difference here, so 6.8 minus 2, the difference is 4.8. And in this direction, the difference is 2. 4.8 divided by 2 is what gives the slope. Oh, no, 4 point. Did I calculate this wrong? 6.8. Oh, okay, hold on. Yeah, 6.8 and 2, 4.8. Oh, I'm sorry, divided by 4. Thank you. 4. There we go. 1.2. Okay, I hope this has helped.